I'd like to talk now about a side reaction of diazotization. This occurs at 25 degrees Celsius. NaNO2 plus HCl at 25 degrees produces what we call an azo dye. Now you'll recall that the ones we talked about earlier, all of these nucleophiles were added while the temperature was at 0 degrees. If we were to raise the temperature to 25 degrees Celsius before we add the nucleophile, what's going to happen is that we're going to end up getting this particular side reaction. Now the process involves the amine reacting with the NaNO2 and HCl to form the diazonium salt. But the thing is, only about half of this will react to form the diazonium salt. The other half will react with the diazonium salt we formed, and we will end up getting this azo dye product. This is clearly an electrophilic substitution because what's happening is the aniline group is donating electrons to this, which is the electrophile, and it's the H plus that's being substituted. Now it always goes to the para position. That's because this group is so large that it's difficult for it to come in here and attack ortho. We know as an aniline but we should be getting ortho and para products, but due to the size of the group we only end up getting the para product. Right, so you can see the mechanism as we go here. We end up with this azo dye, which is one of the very first synthetic dyes that was ever produced. Right, let's take a look at an example. Right, so we've got this compound here. We've got NaNO2 and HCl, and I've been clear to state that it's at 25 degrees Celsius, which means that we're looking at the formation of the side product and not some kind of diazonium salt reaction like the ones we talked about earlier. Alright, so the first step is we're going to take this compound and we are going to react it with NaNO2 and HCl. Now when we do that, we're going to end up with the diazonium salt. But of course what we're going to do is assume that not all of this is actually reacting with the NaNO2 and HCl. So we're not going to get 100% conversion to this diazonium salt. What's going to happen is about half of this will be converted to the salt. Now the other half is free to react with the salt. Now I'm going to turn this around so we have the room to do this. And we're going to put the NH2 group up here, and I'll put the carboxylic acid group here. Now we know what's going to happen is that the compound with the diazonium group, diazonium salt, will end up adding para to the amine. Now, not coincidentally, we've got a carboxylic acid group here, and that actually will direct meta to the carboxylic acid group. So it is also directing to the same location. So the amine group is directing here, and the carboxylic acid group is also directing here as well. So that's good. So don't forget to add on the groups that are also part of the diazonium salt. And all I've done is just rotated this around so that I can get the mechanism. Alright, so we're going to take electrons from the ring, and then we're going to take 2 electrons from the NN triple bond and put them onto the N, and that will neutralize the N plus over here. So now I'm going to redraw my compound. Okay, so that's up there. Now we're going to end up with a positive charge on this C, and we'll end up with our NN double bond here. Now remember that the N has connected to the C that is para to the NH2 group, and when it did that we lost this C here lost an electron and became positively charged. Now there's still a hydrogen attached here, and that's the hydrogen that would have been originally attached over here. Alright, so there we go. That gives us we're getting close to the diazonium salt now. Now we'll lose the H plus by reforming the bond and getting this back to being aromatic. And that will give us our final compound. Making sure, of course, that I include all the groups that were originally attached to the original compounds. Alright. And there is our final product along with the mechanism used to form it. Now remember, this is an electrophilic substitution involved in this side reaction that's at 25 degrees Celsius.